the model is simple. We have a couple of distribution centers, supply, and few customers. That's the connection between them. So, and let me run the model to show how you may benefit from inside-4-walls logic. So I just click on the object, and now we are inside a distribution center. So all this animation, all this visualization shows you how this distribution center works. Probably in the most of the cases, I think, you will not create such sophisticated animation. It can be much simpler, actually. But what I want to show you, I'll just run it a bit faster. So let's say we change the number of forklift trucks to 2. Yeah, and you see immediately the service level starts to decreasing. Yeah, this is how those inside-4-walls logic and sorry. And now I change back to 30. Yeah, we see that again how it influenced the service level. So again, this is how this inside-4-walls logic is linked to this supply chain network level. So, and again, what you have here is important to the performance of your supply chain. So, and by the way, yeah, this is extension. So you may look at the just model. This is for those who are familiar with anyLogistix, this is a typical flow chart which describes some processes inside your warehouse. Again, I think that in the most cases you do not need that sophisticated models inside your objects because it may be simplified a lot. But again, this is just for demonstration purposes. So, another example. It's called simulation online shop. Online shops. So let's say we are going to run internet shop in Czech Republic. So how it works? So we have the online shop. What's the difference of online shop with just the traditional way of selling goods? Because the people may exchange their opinion with others, and those opinions may influence the purchasing behavior of other people. So basically to say, once we introduce this internet shop, it means it will completely change the purchasing behavior. If other customers just check the rating of different warehouses, it may decide to buy or not to buy depending on this rating. So, and in this example, what I showed that the inventory dynamics is probably the most interesting thing to look here because of in that model it works in the following way. If product is delayed, I mean if let's say like Amazon Prime, yeah, we have an agreement with you that with the customer that will deliver you within 2 days, and if I'm late, the customer has the right to reject that delivery and just return it. So, and then I may leave the positive or negative feedback with some probability. Certainly, with the high probability, I'll leave a negative feedback, and with the low probability, I'll leave a positive feedback, right? That's how it works. If you are satisfied, you usually never go to the shop and say, okay, guys, I like how you work. So in the most case, but if you just pissed off with the shop, suddenly you will go and leave your feedback everywhere. So, and here you may see that once the company is not able to match to match the service level defined, the people start to leave the negative feedback, and as a result, many goods are returned to the customer, and you have much more inventory than you actually expected, finally, which leads to certainly much more inventory on hand, which you have. It also leads to the things like bullwhip effect, again, because of the same reason. So you are finally order much more than you have to. That's the bullwhip effect statistics. So, and you may see again how it's changed with the time. So, with that example, I would like to demo you how that purchasing behavior may influence your supply chain, finally, and how it influences your cost. And again, guys, I'm sorry for this mistake. Was modifying that example yesterday, trying to bring some additional logic there, and yeah. So, yeah, please.
Could you give me an example of the output from a dynamic simulation model feeding an analytical optimization model?
Dynamic simulation model.
Yeah, so your slide said the results from the analytical formulations and from the dynamic simulation formulations are used as a feedback back to the anyLogix supply chain model. So I can totally visualize that happening within the dynamic simulation piece.
Thank you for reminding me. Yeah, that thing. So I was so disappointed by that mistake. So, oh, by the way, it's customized object. So I modified that with anyLogix, and that's probably made some mistake there. So, I mean, I developed an extension. This is extension online shop. This is extension. So. Network optimization. So what you can do in ALX, if you have the results of your network optimization or greenfield analysis or dynamic simulation scenario, so you may convert those results to another scenario. Yeah, in this case, for example, we have 10 results for the network optimization. So you may just select them and say, I want to convert this scenario to the dynamic simulation scenario. So during that conversion process, what ALX does, it extends the data which is needed for the network optimization with the parameters with the characteristics which are needed to run dynamic simulation. For example, it creates some inventory policies. So in the most cases, this is min-max policies. So in some cases, some different types of policies depending again on the structure of the supply chain. So, but the beauty of that you should not just develop that dynamic simulation model from the scratch. You may just convert the results of your network optimization or greenfield directly to the dynamic simulation model, and then you go to the dynamic simulation, and let's add a, available inventory. Yeah, I'll add just available inventory. I'll say that for the object, sorry. I remember there should be port. Yeah, Port of Houston. So now what I did, so I added statistics available inventory for the object Port of Houston. So and want to add it to the, pardon? Yeah. Selected the representation way, that will be line. So, and I just added this to the dashboard here. So, run the model. You see, so again, that was a simple optimization, right? So, and the model is simple too. So, and now you see how this inventory dynamics at Port of Houston, this side, is changing all the time. So again, what I did, I just convert the results of network optimization to dynamic simulation. And then you may work with this model further to modify the policies, to make them more real, to add some logic which you want to take into account and so on. But at least it's very easy to get that first draft from which you will then create the final model for your supply chain, final dynamic simulation model for your supply chain. So, no. I think that's all with the presentation, probably. Cool. Oh, safety stock, yeah. And another interesting example I also would like to show you, this is a safety stock. Yeah, next one. Yeah. Yeah, safety stock estimation using the dynamic simulation. I'll explain you the difference. By the way, how many of you are familiar with the methods which are used to estimate a safety stock with the analytical one? Okay, pretty many. So, yeah, with the analytical methods, when you do this estimation, first you assume that all the variability is described with the uniform normal distribution. Sorry, with a normal distribution. And another difficulty of that if you have a multiple echelons in your supply chain, you have to forecast the demand for each next echelon in your supply chain, which is actually not so easy thing to do. While if you are talking about a dynamic simulation model, you already have everything there. So you have inventory policies, you have sourcing policies. You may just see how it works, right? And what we do in the dynamic simulation model to analyze safety stock. So let's say we have the inventory policy, and this is a reordering point. So this is the quantity until which we order. So we introduce so-called redundant safety stock. We know in advance this is much more than you need. Then if we have the ideal inventory dynamics, that's the dynamic we will have. So once we reach that point, we get the next portion of inventory and get to that point. So, but in the real world, it's never like that. So in the real world, it may be like that, for example. So, and in the dynamic simulation, since we introduce this variability, the demand variability, the lead time variability, it will also work like that. And what we do in ALX, we run that experiment multiple times, and then we measure how much of that redundant safety stock was required by the dynamic simulation model to provide the service level you defined. For example, if you want 100% service level, that's the redundant safety stock you need. Oh, sorry, that's the safety stock you need. Does it make sense?
See, this earlier safety stock was, assume that this was a normal distribution or any distribution. The earlier safety stock was defined on the basis of that distribution, correct? And when you are running the simulation, you are using the same distribution to generate randomness. So why would eventually the numbers come to be different?
Yeah, no, you may use any kind of distribution. It's not only normal, you may use any kind of distribution for the demand as well as for the lead time. So not only normal, so you just describe the distribution you actually have. Why always just describe that with a normal one? So, and even with the normal one, if you do this calculation, so you may calculate this safety stock within a 3 sigmas or 2 sigmas.
Yeah.
So if you want to calculate something in between, it's again a problem. So while with that approach, again, you may define any demand variability, any lead time variability. It's not only normal. You should not do this forecast for each echelon because if it's done automatically, just using the inventory policies you have inside. So you should not just even care about that. So, and that's why you finally get the much more reliable estimation of the safety stock. Does it make sense? Yeah. Could you please switch to?
One more question.
Oh, yeah.
Safety stock here, I'm guessing since it's dependent on the forecast, does it calculate very often, or you have an organization policy of determining the safety stock, and that unless you review it again, it doesn't change?
Yes. So certainly we assume that if the structure of your demand or the variability of your demand is changing, then you will recalculate the safety stock. So it's not like, you do not assume it works like at operational level. This is more like a tactical one. Let's say you do the forecast, I don't know, for 1 month, for 1 year, do these calculations, find out the safety stock which you will use for the nearest future. If your demand pattern or lead time changed, then you do this calculation again. So is it the answer to your question?
Yeah, so my question was, it does not have to be calculated very often.
Oh, yes, true. So, we have a special, sorry, that's not this example. Safety stock estimation for the cold chain. Yeah, this one. Sorry. So we have like a cold chain in the UK, and want to calculate the safety stock for that chain. So we have the demand variability, which is defined in demand table. See, in this case, we use not normal, we use uniform distribution. So we also have some variation for the lead time. So to run that experiment, what do you define? You, again, as well as in case of risk analysis, you define the number of replications you want to run and how many processors you want to use for that. Because of default, you use just the number of processors you have on your machine minus 1. So by default, in order you would have just one processor to work with the user interface, because otherwise everything will be freezed. So again, in order to save time, I will not run that experiment right now because 10 replications will get some time. So I just want you to show the results. So that's some recommendations for the safety stock at different locations. Oh, sorry, for different, in different locations, and what you, in different products, yes. And what you may look at, again, this is the histograms. See, now I run only 10 replications. This is why you have that histograms not as beauty as they could be. If you run like more replications, let's say 30, so they will be more soft. If this is the right word, what to explain what I want to, but I think you understand. So, and looking at that histograms, you may decide how much safety stock you need. Basically, let's look at that one. For example, you have a product, vitamins, so, and it says that safety stock of 16.7 units, very enough in one case, in 17 points, very enough in 4 cases, and so on. And this is a CDF, cumulative distribution function, which says which you may use actually to decide which safety stock you want to use. Basically, one of the problems with the when you use the product like ALX, there is a barrier between using different approaches because of you have to just create your model from the scratch once you switch, let's say, from network optimization to the dynamic simulation, or you want to do transport optimization. So, and with ALX, you may just remove this barrier because of this conversion feature. You may just convert any scenario to any other type of scenario. For example, if you do the dynamic simulation, and at some point you want to do the transportation optimization, so you may convert the dynamic simulation to transportation optimization, find the routes you want to use, and then convert them back to the dynamic simulation model. So that's how it works, and we think that's a pretty cool feature.
So I have a question here. When we are converting the model into various different scenarios, you mentioned that various assumptions are taken automatically.
Yep.
For example, inventory.
Extended, yeah. For example, if we have like the network optimization scenario and want to convert this network optimization results to the dynamic simulation, ALX will extend this data in order it would match the requirements of dynamic simulation experiment. It adds some default behavior like inventory policies, for example, in order you could just run the dynamic simulation here.
So will it highlight these different assumptions that it has taken in the data?
Oh, yes. Well, we may show you all these details if you want to, probably after the seminar, if you, during the break, if you want. Yeah. Yes.
So can you go back to your previous slide? So when you transfer or convert from a transportation optimization, for suppose, to a dynamic simulation, is it real time or you have to stop the simulation then feed it back?
Yeah, you stop the simulation, then convert the simulation to transport optimization, then back to the dynamic simulation and run dynamic simulation again. It's not, well, that's actually a good question. For example, yeah, you could find these routes, let's say, dynamically, but it takes time. I mean, this optimization problem, in particular, if you are talking about like even just tens of facilities, if we each time, if we for let's say to organize each transportation, if we call this optimization module, then it will take time. So, and it's from technical point of view, it's doable, but it's not like a standard scenario again because of this optimization. But the simulation model will slow down significantly. That's why we didn't make it like a standard feature. Just some summary of why that supply chain analytical plus simulation modeling. So I think we are taking into account the results of your exercise. I should say that until now, very few audience managed to answer all the questions. So I'm really amazed with that. So yeah, the advantage of this combination, dynamic simulation with analytical modeling, is huge because it actually allows you to address the supply chain problems you have at the higher quality level than it was available before. So yeah, you may consider all this inside four walls logic. So you may test how your supply chain works, how to improve your supply chain. So certainly it gives much more flexibility than just using network optimization. And what is interesting, that the annual report, which was written by Deloitte, it says basically that 75% of supply chain professionals plan to invest into supply chain optimization in the next 2 years. Well, into this and next year. Basically, it means that this technique, the supply chain dynamic simulation optimization technique becomes like a commodity product. So the more and more supply chain managers are using that and just think this is like the standard way to go if you want to improve your supply chain. Rajiv? Rajiv, how much time do we have?
15 minutes we can go.
3 minutes?
15 minutes.
15 minutes, okay. So I'll just briefly explain you the cases. So that's the case of that's probably one of the biggest retail company in Russia right now. So they sell various kind of electronics. So the company background, so they have presence in more than 350 towns in Russia with the 700 stores. So, and they have like the 3 major distribution centers from which they supply those 700 stores. So what they wanted to do, they wanted to find the optimal distribution centers and locations, sorry, and how much capacity they need at those warehouses. So also they wanted to introduce things like cross-docking stuff, all those things. See. The interesting thing about their supply chain, so that's probably what is every supply chain has, but in their case, that's probably the most interesting thing. So again, probably doesn't make sense to talk much about that, so let's just go directly to that. So they have a like unique replenishment and transportation policy. So let's say they have a distribution center here. This is close to Moscow. They have a customer here. This is close to the Black Sea. So, and let's say in this case, customer means their store where the inventory drops below ordering point. See, and at that event, they send the request to this distribution center, and this distribution center planned the shipment, but they never deliver directly to this store. They always deliver to some stores on the way to this one. So what they do, they schedule this delivery, so it goes first to this store, and their inventory just increase even before reaching this ordering point. Then they go to the next, and again the same, it increases because of even before reaching the reordering point, while this obviously goes down. So, and once they reach this one, their inventory again increased. So, don't ask me why they have that policy. I have no clue. So they said that's their practice, so they want to use it. They think that that's efficient and so on, and they would like to take that policy into account when they solve the problem they have. So, and that's some explanation of that policy. So for example, the orders can be done once per 3 days, so you cannot do this more often. You cannot order the products every day. You always have this time frame. So and at the same time, you have to order at least once per week. So even if you do not drop below that level, you have to order once per week. So and then the transportation is done within 3 days after you order, and also there is some limitations on the truck size. And by the way, those routes, they are not predefined. They are created dynamically based on the current situation. So, and what basically was done? So, the optimization was used to find the optimal location for the distribution centers. So the criteria was the total expense. So there were some constraints on the service level. suppliers' expenses too. So that's the characteristics which were again taken into account. That's probably a pretty standard optimization problem. So again, as an output of the model, one of the things I would like to underline, that's one. Losses because of out of stock. That's the parameter they were interested to calculate. And again, there were no way to calculate that with the analytical modeling, just because to calculate that losses because of out of stock, you have to calculate, model the demand that customer just come to your store and could not buy the product he or she would like to. So that's why they needed to use dynamic simulation to do that. Not only because of that complex transportation policies, but also because of some other characteristics which cannot be calculated in other way than dynamic simulation. So again, the service level, that is also about dynamic simulation. Yes, that's some results of that project. So probably the most interesting thing that it should be that all the expenses were, this one, all the expenses like the software and consulting services were paid off just after 2 months of implementation of that solution. I think this is a wonderful result. So, and also they finally get a decision support system which they use on their own. So they may modify some parameters in ALX and then solve the problems they have. Another case, for the Russian telecom provider, this is the biggest telecom provider in Russia, previously owned by government, now it's private. So, and since it was owned by government never worry about expenses, because that's, they just get the money from one pocket and put in another one, so they don't worry. So, and they faced with the problem of optimization of the network they had. So they had many points of sales, like more than 150 warehouses. Again, this is a telecom provider. Yeah, they do not sell like big equipment, or they do not sell oftenly in general. And why did they have that large infrastructure? This is only because of before it was owned by government, and they had to just optimize their network in order to make it more efficient. So as I said, they would like to develop an optimal logistics network. So also they checked some assumptions they have, like they had to have 1 or 2 tier supply chain network, what is the cost associated with the implementing various scenarios and so on. So, and basically what Deloitte did for them. So first they did a baseline scenario. So in ALX they reproduced the structure they have, and the accuracy of the calculations, or the result they had finally was 99%. So, I mean, the model which was created by Deloitte and ALX and the reality was that close to each other. I think, again, that's wonderful metric, I think. So then they test different scenarios, like optimization of number and capacity of warehouses organized in single tier network. So another one was more radical. So they just would like to change everything. Like if we just forget about what we have and create it from the scratch, what will be the savings and what will be the structure. And actually the second scenario which they finally choose was something in between. Like if we optimize the number and capacity of the storage facilities they have, and we create a 2-tier network. So that was the savings they finally calculated, and they choose this scenario to go. As to results, but it was like a step-by-step plan how to implement that scenario. So they also test some inventory policies, or how to work with the inventory, I would say that way. So that's some reduction they finally experience after 1 year, since 1 year after implementation. So which is again pretty good. Yeah, and now they have like the automated solution which read the data from the ERP system and do some optimization, suggesting them some ways to go, how to make their supply chain network better. And they have a special BI tool. That's exactly this scenario I mentioned. So they run the optimization and then use their own BI to visualize the data. Yeah, that's basically all. So any question on the previous slides, or maybe that one? Yeah, I know you're all tired. So
Well, what's the case study? What was the result of the transportation policy? Did it change?
say it again.
The transportation policy, did it change in the first case study?
No, they did not want to change that, but they would like to model that policy. And that's what we did with the dynamic simulation part. So again, we argued with them a lot if this transportation policy is effective. They're 100% sure, even more than 100% sure, that they do not want to change that. They think this is the policy which they created during the years of operations, and they just would like to take into account that policy when you do the network design and optimization. That was their requirement.
What was the solution to improve the service level in that case?
Hmm?
What was the solution to improve the service level? Did you create like an intermediate hub or something closer to the PCs, or what are the
Yeah, finally what we did, we changed the places for these super distribution centers, the basic one they had. So also one of the change at that time they would like to do, they already did it, so they would like to be more online than offline. So, and they were wondering where they have to, well, how to make that transition, because the idea was initially to share the space of the stores they have between like online shops and offline shops. So, and that was the part of the calculation and dynamic simulation, if they can do this. So, and what will be the service level they provide for online shopping, because it was even more important than offline. Because if you order something at the website and suddenly you expect to get it, right? If you're not, then you'll get this negative feedback, which, yeah, I showed at this online shop example. So, and basically, yeah, they just calculated two scenarios, like we leave, we sell only on offline, then we go to online, so how to make that transition, and what should be the final structure if we sell the most of our products online and only like the 30 or 40% offline. So what should be the ideal structure in that case? But they did not want to change this transportation policy.
And what was the minimum, last question, so what was the minimum success criteria? Was it the improvement in service level, or was it reduction of back orders? What was the success criteria for the...
Success criteria, yeah. So service level, that's on the first place, and second, cost. Cost means that's the cost for the facility and the transportation cost. So they were mostly interested in those two. Yep.
So from modeling perspective, when you had a custom inventory policy or a custom transportation policy, how does that get integrated into your network optimization formulation? Meaning to say, because they had a fixed transportation or inventory policy that had to be modeled in, how does it affect network optimization?
Yeah, good question. Again, that's always a confusion between like the dynamic simulation and optimization part, because in optimization but you cannot take into account such complex transportation policies. So what you can do, you may just create like the set of potentially good solutions and then add these details with the transportation policy and simulate them, and then analyze the simulation output from the service level point of view or the cost point of view, for example. That's what we did in this particular case. So finally, they use like the dynamic simulation model to estimate all the potentially good scenarios and choose the best one. More questions? Yes.
Further to that example, where you said they were transitioning to online sales. So when you looked at simulation scenarios, you mentioned that they were looking at certain distribution of product portfolio, something for offline, something dedicated to online, and something available at both.
Yeah, correct.
Right. That is on the product side. Now, thinking of the fulfillment side, since they had a unique policy of distribution centers and stores, was there some scenario simulated for online sales fulfillment, or how the order fulfillment would change? Did you explore that? Or
yeah, that's exactly was one of the part of their goals. So they would like to see how their service level will be changed and how their facilities usage will be changed once they introduce these online sales. Because again, the idea was to share the space they have at the store for both like online sales and just offline stores. Because they saw that the offline stores becomes less and less popular, but at the same time they still had a pretty lot of traffic there. So yeah, they just created the dynamic simulation model for different scenarios, like these with online stores, without online stores, and also we implemented some this facility rating policies, because they had some cost, like, okay, if I extend the facility, then I'll have to pay that much money. So, and they tried again to establish that balance between, on one side they had the space they needed, on another side they had the cost associated with that space, and they just tried to find the right balance between those two, if you are talking about the facilities, line stores. So yeah, actually it was a pretty complex project with quite a different number of goals, and they actually a lot of different scenarios were tested, as well as like just pure online, just offline, this mixed, and how to do this transfer. So that's yeah, basically what I want to say. That's well, almost any option they were considering was tested. So, and again, it was just a usage of both approaches, like the optimization and dynamic simulation, and probably more dynamic simulation, because of with the optimization, yeah, even at least in Russia, honestly, yeah, it's pretty centralized country, and the decision of about some disease or super disease was pretty obvious, that at least one should be located in Moscow, another one in another big city in the middle of Russia. So Novosibirsk, as I remember. So it was pretty obvious for them, and they just like that network optimization confirmed that. But the most of the challenge was exactly related to that dynamic simulation part, to that transportation policy, service level, and how they work with these facilities they have right now, and which facilities they will need to have in the future. So, more
This
questions?
dynamic simulation, because you know this analytical modeling may be done at a bigger scale, correct? Whereas in dynamic simulation, you may require much more level of details, correct? The events and the stochastic nature. So, is it possible to, you know, instead of copying the entire model, like take a subset of it and do, how do you propose to do
Yeah, you may create that from the scratch too, and this is what we'll do during the training tomorrow. Sorry. So yeah, you may create that from the scratch too.
I mean, instead of, you were showing an example where the analytical analysis was taken, transitioned to a dynamic simulation, but the whole model was taken.
Yes.
What I'm saying is we can take a subset of it also.
Subset of network optimization. When you do the conversion, no, but once it's converted, you may just delete what you don't need. That does it make sense? So, I mean, you may do this conversion if you, well, when you do the conversion, you cannot select which part you want to convert, which you don't want to convert. So, because it may lead to some unpredictable results. See, that's why you convert the whole scenario, and this in this converted scenario, if you don't want to have something there, you may just delete those objects from there, and that's all.
While defining the criteria in these simulations, right? So can we also give a priority that this should be looked first and then the other criteria? For an example, like when we were defining it, the two truck size that we have inserted was say 2.5 ton trucks and a 7 ton trucks. So whenever the quantity is less than 5 tons, a 5 ton truck should go. So is there a priority that can be defined in the same thing? Because there, in this particular case, there was a scenario. If I'm taking a 5 ton trucks, the value would be more, right, per tonnage. So can we have do we have a priority that always look for 5 ton? So any priority system which is available in the system?
I actually talking about like the different ways of transportation depending on something. Yes, you can do this. So we have a special like the selection mode, so path selection mode. So there you may define the rules based on which you may choose this or that. Path in ALX means the transportation, means of transportation too.
And the priorities can also be assigned to say.
Well, when you define the rules, yeah, it can be priority too. So, more questions? Again, I would like to thank you very much for coming to our seminar. If you have any question, you are very welcome to contact us. You may contact me directly or Rajiv. If you, again, need additional information or something, to know something about our company or products, you're very welcome. And hope to see, well, we'll see at least half of you, right, at our training session. Thank you very much.